So when dealing with AC electricity, it's really useful to not talk all the time in terms of either the maximum values of the current and the voltage, or in terms of the constantly changing values of the current and the voltage. And instead we talk about a kind of an average value. Like if you took the sine curve and you chopped the top of it and you shoved those bits into the corners, what that value would be. Okay, the overall kind of average. Because it's a sine curve, it's not going to be just halfway up. And this is really useful because this tells us about the kind of the average amount of power that we can rely on coming from our AC circuit. And obviously that's going to be really useful when we're considering what type of devices and so on we can use. So there's there's a derivation for this, which I can show you if you're interested, but otherwise we're just going to work with it, that the root mean squared value, the kind of average value, is the maximum value divided by square root 2, and the same thing here for the current. Okay, that means that the root mean squared value is about 70%, I guess, of the maximum value, and we can use this to find all sorts of things out. For example, our electricity supply is 240 volts and 50 hertz. This is the root mean squared value. Now let's say we had a device that was super sensitive to maximum voltage and it couldn't work if the maximum voltage was too high. So we would need to find out what Vmax is for our power supply, and we can do that using this formula here. We know that the RMS voltage is 240 volts. If we times that by square root 2, we'll get the maximum voltage, and that works out to actually be about 340 volts. And we can do the same with current if we've got an especially sensitive situation where we need to be concerned about the maximum voltage current that's running through it, or vice versa. We might be told that you need to have a certain maximum voltage and you want to know what RMS current you can put into it. So these here work together with the ideas of the constantly changing voltage and the constantly changing current to help us solve problems in AC circuits.